Right, in this video, we are given an optimization problem here. It says that a north-south highway intersects an east-west highway at point P. And that's my intersection of my two highways there. That's point P. And then it says a vehicle crosses P at 1 p.m. So a vehicle crosses this over here at 1 p.m. and is traveling east at a constant speed of 60 kilometers per hour. And then at the same instant, so at 1 p.m., another vehicle is 5 kilometers north of P and it's traveling south at 80 kilometers per hour. So the second vehicle, let's assume that the second vehicle is over here and the first vehicle is over here at 1 p.m. So let T represent the starting time, which is basically 1 p.m. Okay, so we're going to use t for that purpose in this question. I'm going to use my speed equals to distance over time formula to solve this. So speed equals to distance divided by time. I'm going to be solving these triangles in terms of distances. So I know that speed multiplied by time is going to equal to distance. So let's start over here with the first car. It crosses P at 1 p.m. So T is equal to 0 over here. And then it travels east at a speed of 60 kilometers per hour. So let's say the car ends up here when it's at the closest distance. So that's the amount of time that's passed. The speed is 60. So I know that speed, which is 60, multiplied by the time that's passed, which is t, is my distance, which is just 60t. So this distance over here is 60t. Now, I know that at the same instant, another vehicle is 5 kilometers north of P. So this whole distance here is 5 kilometers. Now, if it takes t amount of time for this car to travel from here to here, it's going to take t amount of time for this car to travel from here till somewhere here. And then we are assuming that this is the closest distance in this question. So the distance traveled will be from here to here, and the speed of the second car is 80. So I know that if I use the same formula, 80 times t is equal to my distance, which is 80t equals to my distance. So this distance over here is 80t because the car travels from here to here from 1 p.m. till some amount of time. Now, this distance over here is simply the 5 minus 80t. 5 minus 80t. And I'll label small d as the closest distance between the two cars in this triangle. So now I can do my Pythagorean theorem. So t squared equals to 60t square plus 5 minus 80t square. And now that I've set this up, I can solve this. I can basically expand it all out, move the square, and then follow my optimization steps to find the closest distance. Let me start by expanding here. Foiling out these two brackets. And then plus 6400 t squared. I'll combine like terms. The two t squared terms can combine. And then I will square root it. to get rid of the square on the other side. Oops, no more square. And now I can derive this. So 1 over 2, 10,000 t squared, 100t plus 25. New exponent is negative 1 over 2 times 10,000. Oh, it's going to be 20,000 t minus 800. Now I can simplify this. I can just move this to the bottom. There's only 20,000 t minus 800. Now I can cross multiply this over. Well, technically I want to make my d prime 0 when solving for my critical points. So now I'll cross multiply over and the entire bottom will disappear. So I just have to solve for the top. Then I'll divide by 20,000. And I get 0.04. So this is 0.04 hours basically after. So now I have to prove that this is a minimum right here. There's a couple of different ways to do it. I'm just going to use a number line to prove it over here. So my minimum possible value over here is 0. I guess my maximum is what would my maximum? I just put it as infinity. It doesn't really matter in this question. I'll put my critical point over here. So I need to sub in a value less than 0.01 into my derived equation over here. Now, if you didn't learn how to do this number line test, you could always just sub in the lowest value possible, which is 0, and then the highest value possible. But I'm just going to use this here. You just want to do any check that you've learned in school to verify that this is a minimum at this point. So I'll sub in 0.01. And when I do that, I get a negative number, which means that it's decreasing. And I'll sub in 0.05, a number larger than this. I get a positive number, which means that the graph is increasing, which means that this is a minimum here. So I know that t equals to 0.04 is the minimum in this question. So now all I want to do is convert this to an actual time. So if I multiply it by 60, I'll convert hours to minutes, which is 2.4 minutes. And then I'll multiply the 0.4 by 60 to convert the minutes to seconds as well. So it's 2 minutes and 24 seconds, just 0.4 times 60. So the time with the closest distance is 1:02:24 p.m. That's the exact time with hours, minutes, and seconds. And then we need to find the closest distance itself. To find the closest distance, I'll just sub in 0.04 into my regular distance equation over there. I'll just do that in my calculator. And I get exactly 3, and the unit is going to be kilometers over here. And this is going to be the exact closest distance at this time for this question. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.